Good morning, grade 11s. Welcome to Tutorbox Live in conjunction with COVID-19 catch-up courses. I'm Lisa and I'm your maths tutor. So today we'll be starting with the first maths session. Right. Are you guys ready? Are you guys ready? Okay, let's start, guys. Welcome to the first session. Let's just start. Okay, so this is recap of the number system and the laws of exponents. The number system, guys, I already made a grade 10 video on number system, so if you guys maybe missed that part, you can just go and watch that video. Okay, so I won't go through it right now, but then I'll just put it on the slide so that you can see and you know what you have to revise. So basically you need to know this diagram. You also need to know the definitions and the examples. Okay, so you guys can go through this with the grade 10 if you don't remember. Okay, and then laws of exponents as well, grade 9, grade 10, guys. So I won't really do much on this, but I just want to emphasize this part here, right? So it says for x squared, we say that x is squared. For y cubed, we say that y is cubed. And then in the last example, we have k to the power of 6. We say that k is raised to the 6th power. We also have the following definitions for exponents. It is important to remember that we always write the final answer with a positive exponent, right? So this is NB. Always write the final answer with a positive exponent, right? And then a to the power of 0 is 1, right? And then this is only true if a is not 0, okay? Because if it's 0, then it's undefined. And then a raised to the power of minus n, that'll be 1 over a to the power of n, right? So let me just recap quickly on this one, right? Because we have a negative exponent here, we're going to invert the a, so it'll be 1 over a and then raised to the power of n, right? So you guys should already know this part. This is the base, our a raised to the power of n, that's our base, that's our exponent. I'm sure you guys know that, right? And then I just put the laws here and I put some examples. Let's just quickly go through them. So we have number 1, 5 raised to the power of minus 2, that will become 1 over 5 squared. Because the negative exponent, I'm going to invert. Then my base comes to the bottom, and then my exponent changes, becomes a positive. Okay, and then I get 5 squared is 25, you know that. And then for number 2, we have minus 36 raised to the power of 0. Anything raised to the power of 0, as long as it's not 0, is 1. And then we get our answer to be x. And then for number 3, we have 7p raised to the power of minus 1 over q3 t minus 2. Okay, so you can't really cancel out here because we don't have any like terms, but then just use the laws that you've already learned. So this p raised to the power of minus 1, right? Because it's got a negative power there, so you're going to invert your p. It's going to come at the bottom, and then your power is now positive. And then you have your q3, your q3 stays the same, and then your t to the power of minus 2. So now it's 1 over t to the power of minus 2. So now you're going to invert that, and then it's going to go at the top. So that's why it's now t squared. Okay, so here are the laws. You should know these already. Okay, guys, so now on to some grade 11 stuff. Yeah. Okay, so 1.2, we're going to be looking at rational exponents and surds. So it says the laws of exponents can also be extended to include the rational numbers. Remember, a rational number is any number that can be written as a fraction with an integer in the numerator and in the denominator, right? We also have the following definitions for working with rational exponents. Okay, so these are the 4. We need to know them. So it says if r raised to the power of n is equal to a, then r will be equal to the nth root of a, right? For n greater than or equal to 2. Okay, right? And then the second one says a raised to the power of 1 over n will be equal to the nth root of a. And then the third one, we have a raised to the power of minus 1 over n. That will be equal to a raised to the power of minus 1, all that in brackets, times 1 over n. And then this will be equal to the nth root of 1 over a. And then the last one, we have a raised to the power of m over n will be equal to, in brackets, 8 raised to the power of m, close your bracket, all that raised to the power of 1 over n. This will be equal to the nth root of a over m. Okay, and then where a is greater than 0, r is greater than 0, m and n are elements of integers, and n is not equal to 0. Okay, so guys, let me just first do this part, the theory part, and then hopefully these definitions will make sense after I've explained, right? So it says for square root 25, we get the answer 5, right? If we get the square root of 25, we get 5. So we say that 5 is the square root of 25, right? And for the cube root of 8, we get 2, right? So we say that 2 is the cube root of 8, okay? And then, because you can also check it, if they say maybe the cube root of 8, right, is 2, so you can check it by saying 2 times 2 times 2, 2 raised to the power of 3 should give you 8. So you can check it like that. Or even here, because they said 5 is the square root of 25, so you can just say 5 squared and check whether you do get 25. Okay. And then for the fifth root of 32, this should be equal to 2. We say that 2 is the fifth root of 32. Okay. So basically, you're just looking for a number that you're going to multiply by itself like 5 times to get 32. Okay. And that number is 2. Okay. And then now, it says when dealing with exponents, right, a root refers to a number that is repeatedly multiplied by itself a certain number of times to get another number. Okay, it's just like how here we say that 5 was like the square root of 25. Okay, so a root refers to a number that is repeatedly multiplied by itself a certain number of times to get another number. And then a radical refers to a number written as shown below. Okay, next up. Okay, so now let's look at that diagram over there. Okay, so let's start. Okay, let's start here. So we have the radical. The radical is basically the whole thing there. Okay, that's the radical. And then the radical sign is that thing there. Okay, that's the radical sign. Okay, radical is the whole thing. Radical sign is that guy there. And then the degree is the N there. And then the radicand is the A. Okay, let's just look at the following note. So it says the radical symbol and degree show which root is being determined. Okay, the radicand is the number under the radical symbol. Okay, so the radicand is this under the radical symbol, and then this is the radical sign, and then this is the root that we want to determine, right? So they're saying if n is an even natural number, right? If n, this one here, is an even natural number, then the radicand must be positive. Okay, otherwise the roots are not real. For example, we have the fourth root of 16, right? So this will equal to 2. Since 2 times 2 times 2 times 2 will give you 16. But the roots of the fourth root of minus 16 are not real, since minus 2 times minus 2 times minus 2 times minus 2, that won't give you minus 16. Okay. And then it says if n is an odd natural number, right, then the radicand can be positive or negative, right? So for example, you have the cube root of 27, right? This will give you 3. Since 3 times 3 times 3 is equal to 27, and we can also determine the cube root of minus 27, that will give us minus 3. Since minus 3 times minus 3 times minus 3 is minus 27. Okay, so guys, let me just quickly go over this part again so that you guys are not confused. Right, so here they're saying if n is an even natural number, right, then the radicand must be positive. Otherwise, the roots are not real, right? So for example, if I have the fourth root of 16, I get 2, right? But then now, if I take the fourth root of minus 16, right? So these are not real, since minus 2 times minus 2 times minus 2 times minus 2 is not 16. Because remember, if I multiply a minus with a minus, I get a plus. And then if I multiply this plus now from these two with the minus, I get a negative. And then now I have a negative times a negative, I get a positive. Okay, so that's why this statement here is true. Okay, and then however, for an odd natural number, you see here we have the cube root of minus 27. This will equal to minus 3, right? Because if I take minus 3 times minus 3 times minus 3, I'm multiplying it like basically 3 times. So if I multiply this negative with a negative, I get a positive. And then if I take that positive and I multiply the negative, I get a negative. So that's why this is also true. Okay. And then says it is also possible for there to be more than one nth root of a number. For example, minus 2 squared is 4 and 2 squared is 4. Okay, so both minus 2 and 2 are square roots of 4. So if they ask you to get the square root of 4, you know you have minus 2 and you can check with your calculator. It's true, guys. So if they ask you for the square roots maybe of 16, you know that minus 4 and 4 are square roots of 16. Okay, and then now a surd is a radical which results in an irrational number, right? Irrational numbers are numbers that cannot be written as a fraction with the numerator and the denominator as integers. For example, square root 12, cube root of 100, and so on. So these are examples of surds. Okay, so a surd is a radical which results in an irrational number. Next up, let's look at some example there. So the question says, write each of the following as a radical and simplify where possible. Okay, so radical, let's just go back. Remember that diagram, this one here. So you want to write it in terms of this guy. So, okay, so we have the first one is 18 raised to the power of a half. And then the second one, we have minus 125. All that raised to the power of minus a third. And then the third one, we have 4 raised to the power of 3 over 2. The fourth one, we have minus 81 raised to the power of half. And then the fifth one is 0.08 raised to the power of a third. Okay, so you want to write it as a radical. So I just want to go back here, guys. I just want to go back to this part. So you see these definitions. Okay, so you need to know these. All right. So if I have a raised to the power of 1 over n, right, this is the same as the nth root, or taking the radical of a there. Okay, and then if I also have a raised to the power of n minus 1 over n, right, so what I can do is I can take, because this minus 1 over n is basically minus 1 times 1 over n. Because if I say a minus 1 times 1 over n, I get my a minus 1 over n. So it's just basically the same thing. They just wrote it in a different way. Okay. So then, because you know this law here, right, that a 1 over n will be equal to the nth root of a, right? So now you have your 1 over n here. So basically what you're going to do is you're going to put this, right, in terms of an nth root, right? So this will be 1 over a, because remember it's being raised here to a negative power. So I'm just going to invert this part. I get 1 over a, and then I put my 1 there, and then because it's 1 over n, which comes from this part, I just put my n there. Okay, and then this is the same thing as well. Now I have m over n, right? So what they did is they actually split this part here. You have a, and then this is raised to the power of m. Okay, and then I multiply by 1 over n. This will be equal to the nth root of a to the power of m. Okay, so you guys, you need to master these and how they actually like blend in together and how to manipulate them. Okay, let's just go back to our example. So let's look at the solutions here. So we have the first one, we have 18, and then we have 1 raised to the power of 1 over 2. Okay, so now you see that this is actually 18 raised to the power of 1 over n, where n is 2 now. Okay, so we can just rewrite this in radical form as the square root of 18. Okay, so for square roots, you don't necessarily have to put your 2 there, because we know that this means square root. Okay, so you don't really have to put your 2, but for the other numbers, you have to put your number. Okay, then now let's look at this one. Number 2, we have minus 125 in brackets. All that is raised to minus 1 over 3. So this will be equal to, okay, so we have minus 125, all that raised to the power of minus 1 over 3. So remember, you know your law or your definition as a raised to the power of 1 over n will be equal to the nth root of a. Okay, so always change it and make sure that you're left with just a positive 1 over n here. Okay, so what we're going to do is let's use this. Okay, let's use this third one here. So we're going to break it down. So we have a minus 1, and then all that raised to the power of 1 over n. So what they did here was they just took the minus 125 and then they raised it to the power of minus 1 inside, okay? And then now they have the 1 over n by itself, okay? So now they can apply that definition on that rule, right? So now this becomes the cube root of minus 125, all that raised to the power of minus 1. And then there's my 3 there because my n is 3, okay? And then we'll simplify this. So this will be equal to the cube root of 1 over 125. Remember, because this is a negative power here, right? So I'm going to invert this number. So that'll be 1 over minus 125. And then this will be equal to the cube root of 1 over minus 125, right? I can rewrite it as minus 5 cubed, okay? And then this will be equal to minus 1 over 5. Okay, so you can just quickly check with your calculator this part here. Okay, but then because here, the bottom part, you're actually cubing this minus 5, right? Because it's minus 5 cubed, right? And then outside, you're actually taking the cube root. So basically, these cancel out. The cube root and the cubing cancel out, and then that's why you're just left with your 5 there. Okay, then for number 3, we have 4 raised to the power of 3 over 2, okay? So you should already see here, at least you don't have negative, so you don't have to freak out. So you can see that your n is basically your 2, right? But then you want to be left with 1 over n so that you can like write it using that formula, that law that we learned, right? So what I can do is you can just raise it, you can just raise your 4 to the power of 3 and then you put that in brackets and then you power that to half as well, right? So now you have your a, which is 4 raised to the power of 3, and then you have your 1 over 2 there as your 1, representing your 1 over n. Okay, now it's easy. You just take this part here, which is the a, there's my a there, and then because it's raised, n is 2, which is just a square root, so I can just put square root, okay? And then 4 cubed is 64, and then I get my answer to be 8, okay? And then number 4, we have minus 81, and then we want that in form of a radical, minus 81 raised to the power of half, right? So this will equal to, obviously, this will be the square root of minus 81. This is not real. And then we have number 5, 0,008, all that raised to the power of a third. This will be equal to the cube root of this. They basically changed it, guys, into a fraction, decimal into a fraction, okay? So that will be 8 over 1,000, right? So this will be equal to the cube root of the 8, they changed it to 2 cubed, and then the 10 to 10 cubed, because 10 cubed is 1,000 and 2 cubed is 8. Okay, and then now you take the cube root of the numerator and the denominator. Okay, so if you take the cube root of this part, remember here you're cubing, here you're cube rooting, so that will cancel out, you get 2. And then here you're cubing, you're cube rooting, that will cancel out, you get 10. Then if you simplify, you get 1 over 5. Now let's just quickly look at this example. So it says simplify without using a calculator. Okay, so that means you have to use those laws or definitions. So you have 5 over, guys, isn't this cute? So you have 5 over 4 to the power of minus 1 minus 9 raised to the power of minus 1, and then all that raised to the power of half. So the first step, write the fraction with positive exponents in the denominator. Okay, so we have 5 over, let's change this. We just want to work with positive exponents. Okay, so if you change this, remember this will invert, that will be 1 over 4, and then the minus 1 becomes a positive 1 there. Okay, so you can put the 1 or not, it's up to you. And then now you have 9 raised to the power of minus 1. We invert as well because of a negative exponent. We get 1 over 9. And this minus 1 becomes a 1. So that will just be a 1 there. Okay. And then we just raised all that to the power of half. So basically we just changed the denominator part so that we're working with like something that's nicer, because this is a bit nasty. And then step 2, we simplify the denominator. Okay. So now we have a quarter minus 1/9. Right? So guys, this is like grade 6, grade 5 calculations, simplifying fractions, subtracting fractions. That's easy. Okay, so you should be able to do this. So what you basically do is you find the lowest common denominator, a number that 4 and 9 can go into without leaving a remainder, which is 36, right? And then you do equivalent fractions. So this side, this 1/4 should change to 9 over 36, and then this 1/9 should change to 4 over 36. And then you get your answer to be 5 over 36. Remember, you're not using a calculator here, so you need to remember this. Okay, so you get 5 over 36. So now you have 5 divided by 5 over 36. And then all this raised to the power of half. So this will be equal to 5 divided by 5 over 36. All that raised to the power of half. And then I'm dividing a whole number with a fraction there. So I have to tip and times. So this will be 5 times, that is 6 over 5. I can cancel throughout. So now I'm left with 36 raised to the power of half. So you see now it's in terms of a raised to the power of 1 over n. Okay, and then you can use that rule that we just learned. So basically you're taking the square root of 36 and your answer is 6. Okay guys, so here are some exercises for you guys to try. So that's like quick math. So I'll just give you guys let me see, 2 minutes 30 seconds to do this. Okay, start, go. Oh, just to know guys, in case you're confused, you can just like make reference to the laws. I put them there on the right of the slide, so you can just use those. Okay, I think you guys are done. Let's just look at the memo and check if you guys are right. For D, it says simplify the following and write answers with positive exponents. Use the laws you have learned, the laws here, right? So we have the cube root of minus 64 over 27, right? Let's just look at the memo. Okay, so we have the cube root of minus 64 over 27. Some of you already know this by head. So you know that the cube root of 64 is basically 4 and the cube root of 27 is 3. So if you know that, you don't really have to like use this long method, right? But then for those of you who do not know, so the easiest thing for you to do is to basically change the 64 so that you have a certain number raised to the power of 3, because remember you're taking the cube root. So you want a number that you would multiply by itself 3 times, right, to get 64. So that number is 4, right? So you can just change the 64 so that you have a power of 3 there, right? So then that would be 4 raised to the power of 3 divided by 3 raised to the power of 3. And then the second step there, what I basically did was I grouped these two together because all of them are being raised to the power of 3. So basically everything is being raised to the power of 3, right? And then remember, because here you're cubing, here you're cube rooting, those two cancel out, and then your answer is minus 4 over 3. I hope you guys got that right. Okay. And then the second one was saying use the laws to rewrite the following expression as a power of x, right? So you want to use the laws to rewrite this, okay, as a power of x. So basically what this is saying is x times square root of 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 x. Let's look at the memo. So this will equal to x times, okay, if we change square root of x, this will become x to the power of 1/2. Okay, guys. Notice, because we're here, right? So this part, if you change it, it will go back to this part. Okay. So that's why they're saying that x square root of x is equal to x to the power of 1/2. So we're using this part here. So that would be x times x to the power of 1/2 times x to the power of 1/4. Okay, guys, notice that this first square root is actually square rooting the square root of x and the square root of x and the square root of x. So each square root of x is under another square root. Okay, so that's why it becomes x to the power of 1/2 to the quarter to the 1/8 then to 1/16. And then remember that first law, you learned this in grade 9 and 10, so you have the same base. So basically what you have to do is just add your exponents there. Okay, so what they did here for the second step is they basically put these as equivalent fractions over the same denominator, which is 16, and then we get our answer to be x 31 over 16. Okay, so if you guys didn't get this part, just join me in the Q&A session, and then I'll explain it further. Okay. And then next up, we have simplification of surds. We have seen in previous examples and exercises that rational exponents are closely related to surds. It is often useful to write a surd in exponential notation as it allows us to use the exponential laws. Okay. And then now it says the additional laws listed below make simplifying surds easier. So guys, basically you need to know this set of laws as well, and the ones that we just did now, these ones. Okay, so in the summary, I just added these here. Okay, so you notice that at the end of this topic, I'll just summarize everything for you that you can print out and you can just like maybe stick it up on your wall or something like that. Okay, so the additional laws listed below make simplifying surds easier. So we need to know this laws. So the first one, we have the nth root of a multiplied by the nth root of b. This will be equal to the nth root of a times b. Okay, and then the second one, we have the nth root of a over b will be equal to the nth root of a divided by the nth root of b. And then the third one, first we have the nth root of a here, and then we are now taking the mth root of the nth root of a. Okay, so this is a bit hectic, but it's not that scary. So this will be equal to the m times the n there, and then you basically taking the mth times the nth root of a. That's what you're doing. Okay, and then for 4, that's 1, 2, 3, 4. For 4, we have the nth root of a raised to the power of m. This one we've done. You should know this. And then this one as well we have done. Okay, so you should know these two. Okay, so this one, guys, be careful with this one, right? So basically this one here, what you're going to do is you're actually raising this whole thing, the thing in the brackets, to the power of m, right? So first simplify this guy. This guy, you know, it's going to be a raised to the power of 1 over n, and then power it to m. So basically you're going to multiply the m times the 1 over n, and then that's how they got a raised to the power of m over n. Okay. Let's just quickly look at an example. So we're simplifying surds, guys. So the question says, show that the nth root of a times the nth root of b. Guys, you don't really have to say nth root. I just use nth root. So you can use radical or whichever language you want to use, as long as it makes sense. So you have the nth root of a times the nth root of b, right? So this will be equal to that, and then this is equal to that. So they basically want you to show that these laws are true. So for the first answer, we have the nth root of a times the nth root of b. So we changed this part, right? So we already know the law. So this will become a raised to the power of 1 over n times b raised to the power of 1 over n. Okay, and then I see that these are being raised to the same exponent, right? Because remember, there's this law that we just learned now that says if you multiply these two, basically you're going to get the nth root of a times b. Okay, so it's the same thing here. So this will be equal to a times b in brackets, and you're raising that to 1 over n, and then this becomes the nth root of a times b, because that's what we're trying to prove, right? And then for number 2, we're trying to prove the second law. So we have the nth root of a over b. This will be equal to a over b, and then you change that, and then now you raise it to the power of 1 over n. Okay, so basically remember that previous law. There's a 1 here and there's a 1 here, because this 1 over n, the power 1 over n, right, is now going to multiply each power for a and for b. So now this becomes a raised to the power of 1 over n divided by b raised to the power of 1 over n. And then now you can rewrite these as the nth root of a divided by the nth root of b. Okay, right. And then now let's look at some examples with figures. Right, so example 1, we have the square root of 2 times the square root of 32. Okay, so this will be equal to the square root of 2 times 32. Okay, because remember that first, let me just go back so you guys say it proper. Okay, so we're using this law. That's the law that we're using. Okay, let me go back. There we go. So if square root 2 times square root 32, this will be equal to square root 64, which is equal to 8. And then for number 2, we have the cube root of 24 divided by the cube root of 3. So this will be equal to the cube root of 24 over 3. And you know that 24 divided by 3 is basically 8. So now you're taking the cube root of 8, which is 2. So this one now we're using, let me go back, we're using the second law. Yes, there we go. See that? Okay. And then number 3, ooh, okay, I hope you guys remember this one from that exercise I gave you. So now we have the square root of 18, and then we also want to take the square root of the square root of 18. Whoa. Okay, so this will be equal to, right? Because remember, guys, here for square root 81, I think I said 18, I meant 81. The square root of 81 there, so you can actually think of it as there's a 2 there, right? There's a 2 here, right? And then also here, because the square root, there's another 2 here. Okay, so let's just quickly check which law we are now applying there. Okay. Oh, I see it. So we're applying the third law. Do you see that? So we have that m, we have the n, we have the radical sign, and then we have the a. So basically this becomes m times n, radical sign, and then we have our a there. Okay, so here it will be 2 here, and then here it's 2. So basically I'm going to multiply the 2 times the 2, I get the 4. Okay, and then now I have the fourth root of 81, right, which will be equal to, if you know the fourth root of 81 using your head, it's fine, it's okay. But if you don't, what you can simply do is change this 81, right, so that you have a number raised to the power of 4, because remember here you're trying to get the fourth root, so that these numbers can just cancel out and you just get your answer there. Okay, so if we take 3 and we multiply it 4 times by itself, we should get 81. You can just check it. So then now we have the fourth root of this, and then we get 3, because this 4 power will cancel out with the fourth root. Let's just quickly look at like and unlike surds. Right, so 2 surds, the mth root of a and the nth root of b, are like surds if m and n are equal. So if m is equal to n, then they're called like surds. Okay, otherwise they're called unlike surds. For example, you have the square root of 1 over 3, okay? And guys, here, please note, they're only like if the degree, right? If you go back to like that diagram that I showed you with the radical and the radical sign and stuff. So the degree, if the degrees are actually the same, this degree here and that degree, they are the same, then they're called like, okay? And then if they're not, then they're called unlike. So it says, for example, the square root of 1 over 3 and minus the square root of 61 are like surds because m is equal to n is equal to 2. Because here you're getting the square root, which is the 2 there. Here you're also getting the square root, which is the 2. So they're basically like surds. And then examples of unlike surds are the cube root of 5 and then the fifth root of this. You see now 3 is not equal to 5, so they're not like. So basically they're unlike. Yeah? Okay. And then let's do some quick maths. I'll just give you guys, let me see how many minutes. Not even minutes. I'll give you guys 10 seconds. 10 seconds to think about what you have to do. Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.5, 1, 0.75, 0.5. Okay, time's up, guys. Let's just look at it. So it says simplify the following and write answers with positive exponents. So you have the cube root of 16 times the cube root of 4. So you should already see a law that you have to apply there. And then we also have this b here. Okay, let's just look at the memo quickly. Okay, so I put this part for you guys so that you guys can just recap. So now we're actually using these ones here. Those are the ones that we're using. Okay, so let's look at the memo. So for A, we have cube root of 16 times cube root of 4. This will be equal to the cube root of 16 times 4, which is equal to the cube root of 64. And we know that cube root of 64 is 4. And then for B now, so basically we're using the first law, guys. Let me just go back. There we go. That's the one that we're using. And then for B, we have square root of A squared B cubed times square root of B to the power 5C to the power 4. This will be equal to, right? So we have this is 2 here, that's 2 here. So we're still using law 1. There we go. So we have A squared. So first we're just going to multiply this inside here. So A squared, there's my A squared, and then I have my B3 and my B times my B5. This will become B8 because remember, same base, you're going to add your exponents. Okay. And then for C, it's just 1 times C4, which is C4. And then you take the square root of that. Right. And then now you take the square root here. Right. So we have the square root here of A squared. These two cancel out. So you're left with your A. And then you have your B8. And then you have your square root of B8. And then you also have your square root of C4. Okay. So guys, there are different ways of actually working these out in your head quickly. So the first way that I'll show you is, so you basically take, let's say you have a power here. In this case, we have B8, right? And then we want the square root of that. So what you do is you basically take your 8, right, your power, and you divide it by the degree here. So here it will be 8 divided by 2, and then you get your answer to be B4. Or what you can do is the harder, the longer way. You can just break this apart, and then you end up with, that'll be B4, right? And then you put all that in brackets, and then you raise it to the power 2, so that they cancel out and you're left with B4. But I think the first method is actually faster, right? And then for C, we have C4. So here we have a 2. So all you have to do is take the 4 divided by the 2, and you get your 2. Right, so that's it for today's lesson. So in the next lesson, we'll be looking at the simplest surd form, rationalizing denominators, and hopefully solving surd equations. Yes! So all you gotta do is just go to the link below and download the worksheets for grade 11 and attempt a lot of questions on this section.
Alright guys, see you in the Q&A. Bye!
It's not a matter of whether or not we can. Everybody can, but not everybody will. How to turn nothing into something. How tangible are ideas and imagination? Ideas that become so powerful in your mind and your consciousness, they seem real to you even before they become tangible. Imagination that is so strong that you can actually see it. You can actually see it. If somebody cannot see it when it is not here, then it will never be here. Start looking into the future of what you would like to accomplish, where you would like to go, the person you would like to be. Decide what you want, and then act as if you already had it. And that is to believe that what you imagine is possible for you. So the first step is to imagine what's possible. Second step, to believe. Now here's the third step, and that is to go to work and make it real. You now go to work and make it a movement. You make it tangible. You make it viable. You breathe life into it, and then you construct it.
You have a lot to offer. The fact that you're still here means that your business is not through yet. People don't do what they know in life, but what they do is they operate within the context of the vision they have of themselves.
So write and draw and build and play and dance and live as only you can. Make up your own rules. The rules on what is possible and impossible were made by people who had not tested the bounds of the possible by going beyond them.
You must change what's possible for you. You, and only you, are the subject that impacts the burning desire in your imagination. You are living and feeling as if your future dreams are a present fact.
Will it be easy? No. Will it be challenging? Yes.
So you got to prepare yourself. You've got to develop yourself. As long as you're breathing, you got some more work to do. There's something else for you to achieve. Guess what? You're going to make some mistakes. You're going to make a lot of mistakes.
So now go and make interesting mistakes, make amazing mistakes, make glorious and fantastic mistakes. Break rules, leave the world more interesting for your being here. Make good art.
It is possible to start with nothing and become something.